The next version of HomePlug is called GreenFi. And GreenFi goes in the other direction. While AV2 goes into high throughput area, GreenFi goes into low throughput area. And the word green clearly means that here emphasis is on energy rather than throughput. They want to minimize the energy, and so it is designed for home area networks for monitoring and control of energy consuming devices. So basically this is monitoring and controlling, right? So one of the biggest energy consuming devices soon to come out is the electric car. Electric car needs a lot of power for charging, and you really need to coordinate with the energy company as to what is the right time to charge, and so that there is the right price for you to charge. And so all that will be done by these smart chargers which are connected to the internet and can control your device charging. And the same thing will be actually used at the charging stations. For example, there is a charging station here in Washu next to the energy department actually, where the cars can be charged, and right now they are not connected to the internet, but I'm sure someday they will be connected to the internet and there will be proper charging, and by charging I mean proper dollar charging. Right now probably, I don't know, I haven't used them, but I'm sure that probably right now Vashu is just showing it off rather than making money out of it. So all that thing, and including all other devices, will be done. So for that we need a very low power, low data rate version of HomePlug AV, and low cost. So those are the three things: low cost, low power, and low data rate. And so this is GreenFi actually cuts out all the frivolous stuff and reduces the cost, power, and as a result data rate as well. So the HomePlug is covered by 1901, and so is the GreenPlug. HomePlug Green. So this is just one of the profiles. So we already saw HomePlug AV, HomePlug AV2, and HomePlug GP now. This is the green power. They're all part of the same standard, 1901. And each standard has a profile. So what happens, what is the profile? Basically what the standards do is, they generally have many options. Alright? And different companies can decide to implement different options. However, if everybody decided their own options, then they won't be able to talk to each other. So what they do is they set up a profile. They say, okay, like here is a group A, there is a group B, there is a group C. So you select one of the groups to implement. And everybody who selects implement group A selects group A. That way they can talk to each other. So AV is a profile, AV2 is a profile, and GP is a profile. Understand that difference? Right? Profile means a whole set of options that are implemented by this one. And interestingly enough, these are all compatible, theoretically at least, in the sense that AV2 can listen to AV and understand it. And AV can basically slow down AV2 to bring it down to AV, so they can talk to each other. Alright, if they need to talk to, they can bring it down to the lowest cost, just like lowest denominator, just like it happens in Ethernet. If you connect a 10 megabit Ethernet device to a 100 megabit Ethernet device, they can still talk, but they will talk at 10 megabit. Right? Same way here. So now 28 megahertz. So this one uses 28 megahertz GP. That was 2 to 30 megahertz just like before. And it only produces 256 kilobits to 10 megabits. Okay? And it only uses one modulation. One modulation. So the lowest modulation, if you remember the modulation list was given here. This is the lowest modulation, BPSK. It gives you 2 bits per hertz. So you just used one. Period. Done. Simplest one. This is cheapest one. It doesn't require too much of work. So that's how it can be cheap. And so one modulation and no tone maps. And they don't try to store tone maps. That saves on memory as well. So it uses 75% less power than AV and 75% less bill of materials. Bill of materials simply means the components inside it. So when you make a GP board, it has 75% less components than a AV or AV2. So the device coordinates the sleep cycle and may sleep for 2 raised to n beacon intervals. Alright. So what happens is, beacon is what decides the synchronizes all the clocks. So everybody says, okay, now this is beacon time, the coordinator sends the beacon, and then somebody can say, well, I'm going to sleep for every 16 beacons and then wake up every 16th beacon. And so it will set a timer itself, turn off all its circuitry, go back to sleep, no energy is consumed, it will come back every 16th interval, and in the beacon then, the coordinator knows that this guy is going to wake up. Now, it will have information whether it has any packets or not for him or her. And so it will inform that there is a packet for number 13. Number 13 has already woken up, heard the beacon, and then it says, okay, send me that, and then it will be given, and then it can go back to sleep. This is actually what is done in all wireless networks, including on your cell phone. Your cell phone is mostly sleeping. But the cell tower is transmitting beacons, and the cell phone tells the cell tower when it will wake up, and then the cell tower announces whether there is anything happening for that phone. And that's how the battery times, charging times have gone up in the past 2 years, not because the batteries have become any better. The batteries have become some better, but they are not by as many factors as the sleeping has become better. So the devices coordinate their sleep cycles and may sleep for 2 raised to n beacon intervals, for n is equal to 1 through 10. So you could sleep for 1000, 2 raised to 10 is 1024 beacon intervals, and then wake up. HomePlug GP 1.1. So GP was the first one, and 1.1 is the next version. Adds new power management features and for electrical vehicles. So electrical vehicles needed some extra features which are not required for normal devices, and in particular secure billing was one of them, is because there's a lot of money involved in charging the electric vehicle, so they want to make sure that nobody can steal somebody else's information. And so that is possible by GP 1.1. Alright, and I must remind you that basically HomePlug is very well documented by the HomePlug Alliance's white papers. If you go to the website, you will find one white paper on each of these devices. You will find one on AB, one on AB2, one on GP, and those are required readings. You should read them. Now, they don't stop right there. After that, they come to combine many different technologies into one. So if you have a home which has wireless, which has HomePlug, and which has DSL and everything else, and you have Ethernet, right now you cannot switch one to the other. Right now everything is separate. So if you are working on Ethernet and you want to move to wireless, you have to just disconnect Ethernet, restart the whole thing, whatever you were doing on the wireless. There is no coordination. The wireless doesn't talk to Ethernet. Ethernet doesn't talk to wireless. You cannot just transfer your TCP connection from one to the other. You have to break the connection, restart the connection. With new standards coming up, the media should not matter. So that's what it is that we have a convergent digital home network where you could have many different devices, many different technologies, and they could talk to each other. They will be able to talk to each other. For example, wireless can talk to power line devices. So that for that there is a standard coming up called, actually there is a standard already, which is called 1905. So IEEE 1905, and what it does is it puts a layer between the IP and the data link layer. So now really the data link layer becomes totally hidden in that sense from IP. Okay. So the entire home looks like a single data link, single network with automated provisioning, management, and operation. So basically, as we'll show in the next slide, basically all of these things can be managed together. So basically whether it is 2.3, 11, power line communication, or coaxial cable, all of these can be done with one set of protocols. Allows a device to aggregate throughput from multiple interfaces, and that's another thing you could do. You could use them in parallel. Right now you cannot do that. So when you transfer a file, either you use wireless or you use wired. With that you can do parallel. You could do coming on both. A link can be used for fallback when the other link fails. Backup links. So you might have a wireless link which you really don't want to use because it's so slow speed. But if your wired link fails, this will take over. And an abstraction layer, which I already talked about, is used to exchange messages which are called control message data unit, CMDU, control message data unit. So this is the layer, and this talks to the other devices, and those messages are called CMDU. And no changes to underlying protocol is required. So we don't change 802.3, 11, PLC or MoCA, or we don't change IP. We just change this layer in between. So what it is that basically there is a protocol called ALME, Abstraction Layer Management Entity. So this is there is a ALME protocol, and so the messages which are being sent are called CMDU, as we said before. So every device has this. Now the devices can talk to each other regardless of what data layer you have. So a wireless device can talk to a wired device. A wireless interface can talk to a wired interface. And so basically all the interfaces can talk to each other. So ALME allows neighbor discovery, topology exchange, topology change notification, statistics measurement, flow forwarding rules, and security associations. I think all of these should make sense as to what it means. For example, what is neighbor discovery in the same area? So for example, you want to know in your neighbor house whether you have wired device, Ethernet can find out whether there is a Wi-Fi device, right? And vice versa. That is neighbor discovery. Topology exchange and how they are connected, topology change notification if something goes down or up, and so on and so forth. All right. And for example, AV can be used as a backbone. This is just an example here. And existing 802.1 bridging protocols are used for loop prevention and forwarding, and everything else that was there before can still be used. So there is some more coordination basically between these technologies. So now we remember we have two protocols. 1901. What is 1901 for? That is HomePlug. All those versions of HomePlug are 1901. And then we had 1905. 1905 goes on the top of 1901. 1905 is this abstraction thing. Okay, question.
You have all these devices that are communicating over the power line. Couldn't someone hook into your smart meter and get all your traffic?
No. Okay, so the thing is, like everything else, there are two things that you need. One is you need physical security. I mean, if you leave an Ethernet port outside your home, anybody can connect, and so that is bad, right? So physical security is required. Now, even if, let's say in a public place like this, and there is a power plug here, if I connect it, I won't get any signal. Okay, because then there is a protocol security which does authentication. Right? So all of these have protocol security, but on the top of that you really need physical security, because if you just have protocol alone, then there is more chances for the people to hack. Alright, good. So talking about security. So 1905 basically allows security configuration, and there are three methods of security configuration. One is a push button. So whenever you push that button, they start looking to talk to people who are not really secure. So that way nobody can just come and connect to your network. They have to connect at a time when the device has some other device has a push button pushed. So when you have push button pushed on two devices, then they can talk. Even though they are insecure, they can exchange some information saying that your button has been pushed and that you are the device, and then they can exchange security keys for the rest of their life, right? And so that is one way to change. So that is basically what you do. You buy some device from the market, bring your home, push the buttons. Now that becomes your device. So your neighbor cannot listen to your devices because they cannot push the button at the same time. Right? Your neighbor also brought a device with you from the same store, but the time when they push the button, you don't know. Understand that part? Second is you can configure a pass-phase key. This is similar to what you do on Wi-Fi. In your home, you put a passphrase and you use that on all your devices, and nobody knows your passphrase, they cannot use the same devices. So now this one is, in that sense, if they find out, then they can use it. So it's not time sensitive basically, because this is the key. And so just like any other password, you're supposed to change it every few often. So if somebody did find a passphrase, they won't be able to use it again. NFC is the near field communication. And that is, you must have heard about near field communication. In fact, I have few slides right after this. Is that you can bring two devices close to each other and they can talk to each other. So that is one thing, is that if they can communicate through radio and then exchange the information because they're so close. But obviously when you bring the devices, it doesn't mean that if you just stand next to somebody you can get their secret. In addition to that closeness, there is some other action will be required, some other secrets will be required, some other smartness is required before that exchange can happen. So that is NFC. And then auto configuration. So basically the access points, I think basically this is the same repeat of the previous three methods, is that you bring a new access point in your home or in your company, you put it on, and then you go and it will auto configure. It will get most of the information from the network itself, except the key part, and then you have to use one of these methods to do that. For example, you could use passphrase, or you could have a push button, or NFC. So there is a program for the devices are already becoming available for 1905. I have seen them actually at least in the HomePlug advertisement, dealing devices and things like that from different companies. And so those have to be certified that they are compatible with the rest of the industry, and that certification program is called Envoy. I don't know why the name is or what it means. It's just like Wi-Fi is the program for certification of 802.11 devices. Envoy is the name for the program for the device certification for 1905 devices. So what will happen is when you go to a market, you will see Envoy certified, and then they won't say 1905 certified because that is very abstract, nobody will understand that, but Envoy will become a famous word, and then you will start buying Envoy. And Qualcomm calls its technology Hi-Fi, and so they are not using the word Envoy, but I'm sure Envoy is industry standard, while Hi-Fi is just one company's name for it.
Yeah, I mean, the Wi-Fi and the HomePlug have their own security methods. So what's the relationship with this one?
Right. Okay. So the question is, each of these devices, each of these data links, Ethernet has its own security method, 11 has its own security method, and PLC has its own security method, and then this 11 has a security method. And each has its function too. The thing is, if you are going to use 11, if you are going to use 802.3, you need to pass their security gate. However, if you are going to come through wireless, you have to pass wireless security gate 1905 and then get into 802.3. You have to pass 3 gates. Okay? Because if you just went straight to 802.3 means you plugged it in, you are not using 1905, you are not using Wi-Fi, you don't have to worry about them. Right? You don't need their key. On the other hand, if you are going to come through Wi-Fi and you want to use my Ethernet, you better have 3 passwords. I mean, you have password for Wi-Fi.
Yeah,
I mean,
that makes things complicated.
No, I know. For the user, security is always a problem. But the thing is, you basically, one can design a system, which I don't know, probably independent of all this, which is actually right now used in the real world, where they call it single sign-on. Right? You sign on to some system which will give you permission for all of the other systems. You sign on Facebook and you can do shopping in Amazon. That's what is happening right now, right? So single sign-on security is there, right? So one can do that too, but that is independent of all this. All right, good question. All right, then there is one more program that what do we do outside the home? So far we were talking about the home area network, but outside the home for meter reading and for other things, the power company needs the communication, right, with their own devices, and so there is a long range outside the home power line communication. So there is a standard for that too, and that is called 19.01.2. 1901.2, and that communication is somewhat similar to what we discussed 19.9 for PLC, but slightly different because it is low frequency and narrow band, and because narrow band means they don't use 80 megahertz. And so that program is called Netricity. Again, there is a standard and there is a certification program. So Netricity is simply the certification program. So if somebody implements 1901.2, they could claim that we implement 1901.02, and they could write that in their standards. But if they're certified by HomePlug, which is actually doing Netricity, then they can say Netricity certified. Right? So this is a certification program which is given by an independent organization, and it's better to just go with those terms than go by the standard, because the standard allows a lot more flexibility. Netricity guarantees that you can work with some other vendor's equipment. Okay?